on the shark bite, are there any that we want to see, do, go over, have questions about? Number 1 was 5 and then parentheses. Pick whatever variable you want. I'm going to say x minus 3 equals 7. Any others on the shark bite? Yes. So this would be good practice for the range that we were just doing. So let's do it in both sets of notation, interval and set builder. Range, we're looking lowest to highest. So what is the lowest value if this keeps going down? What would our lowest value be? Negative infinity. What would our highest value be if this keeps going up? So this is going to be all real numbers. Other questions on the shark bite? Okay. So you should all have your notes from last class in front of you. Does anyone need another copy of those? So let's talk about the differences between vertical and horizontal transformations. 1, you need to know the direction. Vertical is up and down. Horizontal is left and right. Vertical transformations affect outside things. That'll make sense in a minute. Affect outside things or your y values. And then horizontal would be the opposite. It affects inside things or your x values. Of the different types of transformations, we're going to list out each one and what they were. So for vertical, we had a vertical shift. We had a vertical reflection. Which is when it flips up. So I could put all of this in these. Vertical shift when it moves up and down. Vertical reflection when it's flipped over the x-axis. So flip upside down or flip over x-axis. So that part is a little weird to think about because it's y values, but you have to think about at your x-axis, if it's underneath, the y values have changed. And then we talked about vertical stretches and compressions. So vertical stretch, where it gets narrower. And vertical compression where it gets wider. So this is really just putting all of that information in one kind of table so we can see what all it does. So then for horizontal, it's basically going to be the opposite of all of those things. So we will have horizontal shifts where it moves left and right. Horizontal reflections where it's flipped over the y-axis.
Let me double check this really fast.
We did not talk about a horizontal stretch or a horizontal compression. We're going to do that briefly so you would see what it would look like, but after that, not really again. This is going to seem weird, like it should be the same, but it's going to be opposite. So then these will be all the things we'll have to remember as we're looking at functions, as we're looking at graphs moving forward, and all these things. Today, once we know what they would look like in our minds and we talk about that, we're going to be looking at functions and trying to describe the transformations that happen. We'll be given transformation descriptions and have to write the equation using those. So we're going to draw two sets of axes for all of these. So whether you want to do that all at the same time or wait is up to you. I'm going to label one V, one H, so we can see the vertical translations and the horizontal translations. We're going to be doing that for each of these. So for the vertical translation or vertical shift, that would be it moving up or moving down. So I'm going to use our quadratic parent function. If it moved up from the original, it would no longer be at 0. If it moved down from the original, it would no longer be at 0. So I'm just going to draw two different things to show what each type would look like and show that it could either move up or it could move down. And then for horizontal, we know it moves left and right. So if from the parent function it moved to the left, it would be somewhere over here. to the right, it would be somewhere over here. And I would show that it moved either left or right. I'm going to make a note that translations are also shifts. That's what we've been using. But you could also say it was vertically translated up however many units. It was horizontally translated left how many units. That would just be another word for it. Questions so far? It's not really new information, just a lot of the same things we were already doing. Just putting it all together. We're going to do the same thing for the reflected. Draw in two axes. Label one as V, one as H. If your parent function's quadratic was reflected vertically, it would flip upside down or flip over the x-axis. So it would flip down is what the arrows are trying to show. It kind of looks like another one. There we go. That looks a little bit better. Horizontally, it flips across the y-axis, but if it doesn't shift, it looks the exact same. How did I draw this? Sorry. Was really doing this, switching spots. But I'm going to put a side note that it has to be translated in order to be seen. Then we're going to draw more sets of axes. So this one is just going to be the stretched version. So if it is vertically stretched, I said that it stretches towards the y-axis. It gets narrower. So you can make it a little narrower. And kind of draw arrows showing that it's going towards the y-axis. And I'm going to write that as a note. That it stretches towards the towards the y-axis. Or gets narrower. Gets narrow. You could just say that. That works too. But a horizontal stretch, as the vertical stretch stretches towards the y-axis, the horizontal stretches towards the x-axis, so it gets wider. Because it's stretching towards the x-axis. But then for the compression, it does the opposite. So we're going to draw in two new sets of axes. The vertical compression is now shrinking or compressing itself away from the y-axis, which is why it is wider. So I would write that note as shrinks away from. The y-axis. And then just like the vertical, the horizontal has to do the same thing. So it's going to shrink away from or compress away from the x-axis. So then it will get narrower. So shrinks away from x-axis. So when we see the words translated or shifted, reflected, stretched, compressed, we need to be thinking these visuals in our minds. Or you have your calculator, you could easily graph it for some of them. But some you won't be given graphs, and you'll have to know what those transformations look like so we can write the equation. Do you have any questions so far before we do some actual practice? So in our practice, in number 1, if f of x is x squared, so it's telling you what the parent function is translated 4 units down and 2 units to the right. So until you get the hang of this, I would do whatever's important or find whatever's important, knowing what the parent function is. I'm going to write that as a little note. Parent function, so we know that's the function we're going to be using, we're going to be writing with, is translated, so that means it's going to do what? Shift, reflect, stretch, or compress. Shift. And it says 4 units down. So would that be a vertical or horizontal? Vertical. And then 2 units to the right, would that be vertical or horizontal? Please write a horizontal transformation or a vertical transformation. Now, what I said about the inside-outside helps you figure out where to write things. Because since this is vertical, this is going to go on the outside. And since this is horizontal, this is going to go on the inside. Then we can start to put these things together. Almost all of our functions will have this format, so I'm going to write this over here, up here. F of x equals a, then parentheses, x minus h squared plus k. So when it says inside, that's where it's going to go, inside those parentheses. When it says outside, it's going to go outside the parentheses. And we just have to figure out where it goes. So we would start this off, f of x equals. The A would be if we have a vertical stretch or compression. Do we have any of those? No. So our A can just be 1. You can write the 1. You don't have to write the 1. Doesn't matter. The X value will always be there no matter what. Here's when it gets a little tricky. Remember last class when we were graphing them? Whatever it says is going to be the opposite of what you write. So if it says to the right, you're going to want to write a positive. You're going to do the opposite and make a minus. The reason that is if I put positive 2 into this, it would become minus. If I put a negative into this, it would become a plus. So the formula itself is why it switches. And then your K value is going to be whatever is vertically shifted on the outside. So if it's down 2 units, how would you write that? Would that be plus 2 or minus 2? So that would be our equation for this function that was just described. Knowing all your transformations will make this easier, but it does take practice. What questions do we have before we go on to 2? So in 2, we have the same parent function. What transformation words do you see? Remember, the transformation words are translated, reflected, compressed, stretched. What of those 4 words do you see in this? Reflected. I'm just going to underline it for now, and then we'll talk about what type. And then anything else? Translated. You know that's our shift. Okay. So for the first one, reflected over the x-axis. So this is my x-axis, and it's doing this. Is that a vertical reflection or a horizontal reflection? Vertical. And then if it shifted 7 units to the left, is that horizontal or vertical? Horizontal. So now you have your outside things, and you have your inside things. Those words are interchangeable. So when we were describing them, we were talking about them as shift instead of translated. So now let's start to write this. F of x equals. I said A is if we have any compressions or stretches vertically, but it's also if we have a reflection vertically. So that would go outside first. So it would be -1 instead of 1. So if you put the 1, you don't need the 1. And if it's translated 7 units to the left, would that be -7 or +7? It would be a positive. It's always going to be the opposite. Do we have anything on the outside of that we need to put? Do we have a K value? No. We weren't given one. It didn't say translated some amount of units up or down. So that's it. So don't start making things just because you don't have something. Just do what it says. Okay, questions so far? Now we're going to switch it up just a little bit because the parent function is just going to change. Everything else stays the same except for, instead of it being squared out here, I'm going to rewrite this so it matches this. The inside would still be your absolute value bars, there's just not a square on the outside. Also, I think these words got mixed up. So 3 should be stretched, not compressed. And this should be compressed, not stretched. So we have a different parent function, that's fine. What transformation words do you see? Reflected, translated, stretched, compressed. What of those do you see? Stretched. It should be stretched. That was a typo. I'm just going to underline that for now. I'm actually going to underline that it says vertically because if it's stretched or compressed, it has to tell you what type. Any other transformation word you see? Reflected. With the first one, if it's stretched vertically by a scale of 4, there's nothing else we need to do with that. It tells us by how much, so we're going to use that number. Reflected over the y-axis. So if this is my y-axis and it's doing this, is that a horizontal or a vertical reflection? It's reflecting, but over the y-axis, my arm is not right. Is that horizontal or vertical? Horizontal. So we know this is vertically, so that's going to be our outside thing. And the horizontal reflection will be inside. So then as we write this, it'll still start off f of x equals stretched vertically would be our a value, so we're going to put that out front. 4. Do we have any horizontal shifts? No. But we do have that horizontal reflection, so that's going to come before our x. But that's going to be the only thing that's inside, that negative. Do we have anything else we need to add? Or did we get all the transformations? Are we done with this? Are we missing something? It's not a trick question. No, we're not missing anything. We're done. Do we have any questions on that one? Let's do this last one. We again see that it's been compressed vertically. It tells us by how much. Vertically is still going to be outside. What other transformation word do we see? Translated. And if it's translated up 14 units, is that vertical or horizontal? We're going up. Would that be horizontal? We're going up. So because this is vertical, that's also going to go outside. Sometimes you don't have inside things. It just depends on what the function is. So then we would start to write this. F of x equals, what would be the first thing we write? The 1/2. Do we have anything on the inside? No, besides the x. And then how would we write the translated up 14? Okay, 14. So being able to recognize what's being given, what type they are, what directions they are, where they need to go, really helps you be able to write this. What questions do we have on this one? On the back of this, there are 5 questions, similar to what we just did. If you would like practice on this, I would say try those 5 problems. Let me know if you have questions, need my help. After you do those 5, if you want to work on the Khan Academy for Friday, do missing tests, work on retake stuff, you can come see me to do that. But do these 5 first.